basically. I'm just getting set up real quick and we'll go. We had a fun realization just a minute ago. Our water that we thought was filtered decently well is not. So there's lead in our water. I don't know what the threshold for, you know, being okay about it is, but I can't imagine it's as high as it is right now. So, and basically the filter does nothing. So that's fun. We're gonna figure that out though. Okay, so basically we did chapter 11. It's been a while, so I might have to say a little bit more than I normally do. We talked a little bit about monad transformers. It says it's rather difficult to escape them if you architect your application using Haskell or libraries that build on the concept of monads. This chapter is a bit different from the previous one. And then we look at the implementations of monad transformers in order to highlight some of their shortcomings. So we're going to learn about the shortcomings for transformers, and then I think that leads into the other solutions for dealing with transformers. Excuse me, dealing with monad composition. Which it doesn't happen for free, if people are unaware. Okay. So the n squared problem for transformer instances. Dealing with the transformers using MTL-like type classes or traits requires just too much code. On the other hand, if we do not define these classes, we can only write code that works on specific monad stacks, even though the same code would work verbatim for other ones. As we explained in the previous chapter, for each monad mn, we usually define a transformer version mnt, which wraps other monads inside. And then usually the monad is redefined in terms of the transformer. For example, let me show just a minute. You're gonna have something like instance monad m. Oop. I haven't typed on this keyboard in a while, so bear with me. My touch typing is gonna need a little bit of work. So mt m where, and then like we define our instances as usual. I'm not going to actually save this code, so consider the monad transformer nt with instances then we have like the monad itself, which is just defined in terms of mnt and identity. In addition, a type class or trait monad mn defines its primitive operations. Class monad m at mn m where op okay. Every stack should be a member of monad mn, the layer that mnt could be. Okay, so basically we need to make this work, you're gonna have instance monad m at mn m where op equals, but then also you need instance monad m you know, maybe reader T. This isn't actually valid Haskell code. State T. M where right, and sort of we need to implement every layer of the in other words, with n different transformers and for each type class given n different implement n different instances n squared. N squared problem. You should be able to read. Yep. Okay, cool. So that's the n squared problem with monad transformers. So obviously that's kind of problematic. The beauty is that if you just use the, the beauty is maybe not the accurate way to say this, but the nice thing is that MTL for all the common transformers, all of these instances are already implemented for you. So you don't have to implement them yourself. However, every time you define a new stack or a new monad, transformer that is, you'll need to define every other instance of that. So that's kind of problematic. Okay, it just makes some points about, we could define a macro to write a lot of this code for us, but that it's just not a good idea, generally speaking. So up to this point, monad transformer has been defined as a type constructor that takes a monad and builds up a new monad by adding some additional functionality. This definition does not guarantee that the operations of the wrapped monad are available in the larger stack in a generic fashion, right? So if we have some deeply nested stack, let's say maybe reader state, and we want to use the reader functions, that's not generally the easiest thing to do. So in other words, there is no generic way to lift operations from the wrapped monad. This is the core of the n squared instances problem, because we do not have a generic way to move operations across layers of the stack. We need to write down how each operation moves across each layer. Okay, interesting. On the other hand, if you write the code that moves operations across maybe T, you see a fair number of commonalities. Technique described later in this section. So let me just look these up, I guess, because it's going to be easier. Monad. This should be in MTL. What we want to do. Oh, actually, we want to look at the instances. So here, monad writer with maybe T. Oh, here. Source code. Monad writer with maybe T. Oh, it's okay. I'm looking up here, but it's just because it doesn't go that far. All right, so there it is. So this doesn't look exactly like it looks in the book, but they just point out that you could write this as ask. The right one? Oh, I'm looking at the wrong one. This is tell. Yeah, these are implemented slightly different in the book, so it's kind of hard to draw comparisons. But that's okay. But anyway, the point is that it's like lifting an operation across maybe T simply requires wrapping the return value in an additional just layer. At least for the simpler operations, catching errors requires a more convoluted solution. Da, 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 da. Convince yourself of the previous claim about reader T by writing and comparing several monad MN instances reader T. Now we can write ask. Okay, so we want to look at, okay, I get it. So we're going to do an exercise. Maybe. I don't want to implement reader again. So. So it's like, okay. Lift through reader T. That a generic function lift through exists for various versions of I don't really understand what this means. Monad MN is just, I guess, the outer monad? The reader? I think reader is supposed to be the inner one at the point. Okay. What if we look at the instance? Well, that's exactly what they're doing here. So this, I guess, is map reader T. What is map reader T? I think that this is the generic one. Tell W. But these are lighter. What am I looking at? Confused. Oh, this is a generic lifting function. I see. So this is defined somehow. Don't actually know how. Oops. So I think there's like this monad lift thing. But it wouldn't be under monad writer, it would be under like reader T, I guess. Do zip. How does that lift function work? For the monad transformer, the lift one, you're saying. Also, hi Jeppy, how's it going? Lift. Lift, got it. And we want to look under MTL. This isn't in alphabetical order? Fortunate. Hot tech. I've never heard of hot tech before. That's kind of cool. Sorry, I'm getting a little distracted. Like how this is formatted. I guess so. Tool to use. But there's like no information here. The preamble, document the body. Yeah, okay, so that's kind of cool. Like you write, I guess this would be like DSL, right? That's the term people use for this. Make title, section. That's kind of interesting. What's the other typesetting thing in Haskell? Something Haskell. I forget what it's called. Literate? Is that what it's called? What is that? This like runs Haskell code inside of Haskell or something, right? I don't quite understand. So you could like run the factorial option or something? Rows within your code base. That seems backwards, but okay. Although I guess this is just a style. Okay, anyway, sorry, I got distracted. Lift. Then what do I do? Oh. Package MTL, I think is what I want, right? Okay, so this is the one that comes in Transformers. Oh no, I know who I know who Donald Knuth is. I know he's an important person, but just it's a style thing that I don't fully understand. So this is the lift function that's being called, right? So each of these need to have monad trans, and they do. So that's what allows you to use this lift. Okay, that's interesting. He's a very big deal. I almost bought those books just as like a thing to have. The set of 4 books. I like the idea of like having your LaTeX type checked. That's kind of an interesting idea. I don't really know where it becomes really important. I'm trying to think of a great example of it becoming important, but like it has a compiler, so you could just listen to the compiler. So like you're just listening to a different compiler. So is that better or worse? I don't know. I think I'm gonna skip this exercise because I don't really see the point. Um, Also, the code that's written in the libraries now are not like helpful. Maybe if I look at the older versions, let's see if I can do that. Um, so if I go like grab an MTL like version 1 or something, and then I go look for yeah, I would agree with you. Like as long as you don't write them complicated. Right? If you wrote like a million line LaTeX file, then it would be very complicated. But I mean, like my dissertation was written in LaTeX, and that's I forget how many pages. I think it's up there. I'm not gonna grab it, but hundreds of pages of LaTeX, and it wasn't that hard to make or keep track of. Right. So I want to go look at the source code for like at one of these instances. This one specifically. Well, this is just a class. Okay, so implemented here. Okay, So let's see if we can find it. Right, here we go. This is the instance we're looking for. And this looks more more interesting. Whoops, wrong way. So we'll copy and paste a few of these in here. They're not going to type check, obviously. But what I want to do is find... Oh wait, but this is just... This is not the right one. I want to look at the instances. This isn't the right one. I don't really know what I'm looking for. I think I'm a little confused at what I'm trying to find here. I think what I want to do is find... What is this tilde here for? I don't remember what that tilde does. Yeah, I'm not really sure what I'm looking for here, so I'm a little lost. This is not what I'm looking for. Laziness? Oh, okay. So the strictness annotation is a bang, right? The lazy annotation is a tilde or something. That's fine. Okay, so let's skip this one and hope we can find something more interesting to do. Or maybe clearer. I don't understand exactly what this is asking. Okay, so the previously defined lifting functions for maybe t and reader t become the monad trans instance for each transformer. Okay. By a careful usage of lift, we can combine operations from different monads. Suppose you have two monadic computations with the following types. Okay, so F1. F2. Reader T string maybe bool. Really? No action? Unfortunate. So package. So we need transformers. And that's probably it. Lib. Import control monad trans reader. Then we need to not rename. Okay. Wonderful. Just took a second to refresh, but we got it now. Okay, so considering these two functions, we do not really care about what they do at this point, but here are some well-typed possibilities. Right? Pure 5. Okay. Yep. Apparently the following code will not compile. So let's verify. Do. X. F1. Well, of course it won't. Yeah, this will obviously not compile because we're working in the maybe monad, not the reader T. Yeah, see, it's right here. So it says, since each monadic block must be assigned a single monad, the compiler cannot decide here whether it should be maybe or reader T string maybe. The solution is to lift F1, that is to add an additional reader T string layer on top of maybe. So if we lift, I don't actually know where this comes from. Monad trans class lift, that one probably. There we go. And then now our X should be, well, that's an int. Let's look at the type of lift, I suppose. So you can see the return type is maybe int to, or I'm sorry, the type is maybe int, which is the F1 function, and then we just wrap it in there. So this comes from, so without lift, we operate in the maybe monad. Yeah, I mean, I used it. I certainly used it a while ago. I use it all the time, and I use lift and lift IO pretty often. But I mean, I know how to do this, some of this stuff. I'm more, I'm more excited about getting to the free and freer monads and that kind of stuff. What's up, Oren? How are you? Okay. And therefore, F2 is a compiler error. Okay, cool. That makes sense to me. So it says, by nesting calls to lift, we can add as many upper layers as we want to a computation. The second advantage of monad trans is that we no longer need to write n-squared instances to obtain a working monad transformer ecosystem. Whereas before we needed n instances per monad mn class, i.e. 1 per monad transformer, we now just require 2. Take, for example, monad reader. The first instance is the one claiming that a reader T layer provides monad reader operations. The rest of the instances only exist to lift operations across layers. But now we have a generic way to perform this lifting. They can be summarized into a single instance. That's cool. It says, unfortunately, this solution is at odds with the type inference machinery. Oh. I would agree with that, Oren. I'm glad that we're doing this multiple times. Like we've definitely discussed lift on the stream before. The more the merrier. And I feel like I'm getting more confident with every time we talk about this stuff. So, I mean, I feel like I've implemented the reader T operations like 100 times, it feels like. Okay. All right, so it says the monad trans solution, sorry, while elegant, the monad trans solution to the pollution of instances makes programmers' lives harder, and implementations such as MTL prefer hard coding the n-squared instances. says, these days, the main reason to use monad trans in practice is for its generic lift operation. Yeah, I would agree with that. It's like not as scary, you know, it's not supposed to be a scary thing. The problem is that people make it seem harder than it actually is. You know, there's like the easy way to use it, which is basically just this, and then there's sort of the ability to grok it, which I think is a little bit harder. To use it and to, you know, sort of grok the concept are two different things. That word is becoming more popular, so I assume people know what it means now. I didn't really know until people started using it all the time in programming. Anyway. Okay. So it says, in the previous chapter, we introduced the monad IO type class, which allows us to lift a computation in the IO monad into larger stacks. The type class looks similar to monad trans. It just says, we do not lift a computation from any monad into a larger one. We specifically lift IO operations. IO is the best known representative of a set of monads called the base monads. Because it doesn't have a transformer version. As a consequence, they can only appear at the bottom of a stack, never an upper or intermediate layer. Okay, so it says, it feels so dark in here. It's probably just because it's really dark outside and I'm not used to it yet. Yeah. That's generally true. I mean, I don't know that you've ignored learning them. Like, you're using them effectively. I mean, if you can write, you know, monad transformer that's using this stuff, then you're fine. You clearly understand it well enough. I don't feel confident with transformers yet. All right. Monad IO is a good solution for computations that ultimately run in IO, but it is interesting to consider stacks with other base monads. You might be interested in expressing computation that use mutable variables in such a way that they can be used with both IO refs and ST refs. One possibility is to have dedicated type classes for each base monad, monad ST, monad STM, etc. To fight the duplication, the package transformers base defines a one-size-fits-all type class for any base monad called monad base. Okay. So apparently we're going to write these things. So I need to first get transformers base. So let's do that. Mechanical way. Yep. Never written my own transformers instances. You've never lived, apparently. No, I think it feels like a rite of passage for me at this point. Yeah, mechanical way of composing monads. We're learning that they're not going to be the best way. I can't wait till we get to the point where like I can just like open up what is that called? Polysemi, and just like understand why the things are working the way they work. I did see some sort of talk on that recently that helped me understand a little bit about it. It's like basically that all of the effects are just in a list, and you just like unwrap that list at the type level to perform the effects. I don't remember where I saw that explained, but I thought that was like a really helpful explanation. Okay, and then we need to probably import control monad trans monad base or base? I don't know. I suppose we can just wait and no. Restart that. Okay. So instance monad base io where fine. Hey, what's going on? How are you today, Sir Fireball? The activist Fireball? The most active Fireball? Let's go with most active. This is the C# one, right? I think it's C#. The most active Fireball. All right, so, oh, just control monad base. It's kind of interesting that it's not in trans. Oh, I thought you said that you were running a meetup for C#, but maybe I'm confusing you or like combining two things I know about you into one thing. Does that make sense? Just devs in general. That's good. This is probably... Ooh, that's a good question, Oren. I think that this is just... Yeah. Does it say I need this? Maybe it does. I probably need that. It's a silly question. It's a good question. I like it. But definitely silly. New error. Oh, right. Can I like hide? So if I just do like this, can I rewrite this? How do I hide duplicate instances? Yeah. You have to make sure, you just have to say, like, give a very non-serious answer. You could say, like, Halley's Comet. That's the second most active fireball. Something like that. But yeah. See where I'm going with that? Penguins. Alright. I'm into it. I'm into it. I know there's a way to, like, duplicate stuff. So duplicate, instance, Haskell. Yeah. Isn't it just like a language pragma somewhere? Where you can just write like duplicate instances? Maybe this is old. Replicate? I don't know what replicate means. I'm sorry. Oh, I think you... Now, very confused. Oh no. I'm trying. Sorry, I'm trying to get over this. So there's an instance monad base IO defined in control monad base, and I basically just want to hide it and implement a different one. And I think that there's a language pragma or something to do duplicates without like. I mean, I probably could just wrap it in another type class and then do it that way, but overlapping instances, is that just a language extension? We can try that. Or is that, where do I put that? It's not here, right? Well, maybe it is. Use per. Okay. Hang on. It seems like there's maybe some guidance to what to do instead. Use per instance. How do I do? Yeah, I can't hide type class instances, I don't think. So yeah, it's sort of one of these things that's like a little more specialized, unfortunately. So let's do. No, that's fine. You were trying to help. I appreciate that. So overlapping. Oh, maybe this will work. I don't want to avoid them. I want to just let me do it. Please just show me the answer. Here we go. Maybe it's this. I think overlaps was one of the options. So it goes right after instance. Foreground. So language pragma. Overlapping. Like this? Oh. Yeah, like, yes. Oh, I didn't mean to do that. Shoot. So what does it say now? Yeah, that's kind of what I was thinking. Do I wrap IO or do I wrap monad base? I guess I have to wrap monad base that takes basically two monads. Yeah, probably. Okay, let's do that. I screwed up though. But I think you're right. I think it should just be like new type. Base. Monad base is a constraint? What? Oh, maybe I need to get rid of this. You like that? So I guess I should just wrap, although I need two things. Maybe I just wrap IO and then write monad base wrapper. Yeah. I'm misunderstanding what I'm supposed to be doing here. Wait, can I not do this either? I'm not going to be able to, am I? Maybe I can do this? See ya. Thanks for hanging out. Finally. Okay, there we go. Seriously? You're not even gonna try and format this? It's unfortunate. Did it format anything? It did. Weird. I was expecting it to do something. See you, Fireball? Or maybe you're hanging out and saying bye to Chappie. Unsure. Okay, so now we can deal with this. And apparently we have some alphas in here, which is weird. Second thing. Got it. Thank you for hanging out. All right, so we are lifting a computation from B to M. So lift base gonna take basically don't we just do this? Why shouldn't that be harder? Keep in mind that these are technically different things, right? This is representing the first IO wrap, and this is representing the second IO wrap. I don't know why pure doesn't work there. Shouldn't pure take an A and return that? Maybe I need return. Why would I need return? This shouldn't change anything, right? What's the type here? IO alpha? This might be like just a machine or a type inference issue that I never understand completely. If I explicitly typed it pure IO wrap A or beta, I guess, then I think it would work. I don't even know how to enter that beta into. Well, here's how we can do it. Nope. Not entirely sure why that doesn't work with pure, but okay. Pure should take an A and return, or an alpha, whatever, and return a MA. Seems like that should work, but okay. We need another one of these. Oh, okay, we're gonna take an ST, and we're gonna write monad base ST wrap ST wrap. Oh, but this is gonna take two things, I think. So give me a second. We're gonna get some type errors here in a second. Lift, or we should anyway. So this is gonna take SA. Why is no action available? Where's ST come from? Control monad ST. Wonderful. Went the wrong way. Mm. 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 So this is gonna take. Was this just not? I was just thinking about that. Like, that's literally just identity. Is this not the same thing? Uh, what is linQ? Is that something that Oren posted a link earlier? Okay, so this has something to do with a language that. Okay, that's C sharp. Okay, I was very confused. So linQ, link. Ah, sure. So link has something to do with .NET. Okay, so you guys can talk .NET. I've never done anything other than the absolute tiniest amount of F sharp, and by that I mean like I installed .NET on my computer and ran like basic F sharp code for a workshop. Yeah, I mean this is just id. Doesn't do anything because of the definition of monad base. At least for me. I don't know anything about it. I don't know anything about it. Yeah. You have a Haskell job pick? It's great to hear. I want a Haskell job. I'm not ready for a Haskell job, I don't think. What? There's literally an error here. There's no, oh gosh. Nice. Well done. Well done. In what industry can I ask? Actually, could you guys give me just a second? I'll be right back and we can talk about that. But I need to grab water. So yeah, just give me a few seconds. You like my be right back page? Pretty nice, right? Okay, we're back. Nice. It even gives you that nice little animation. How beautiful. Control Z. Quickly build. Monad trans class. You got it. Oh. What's okay? Applicative TM. Okay. Okay. Oh. Okay, but just for reference, they're discussing a library that Oren wrote, which seems to ease the use of databases in C#, if I understand what you're talking about correctly. So if we take an, I understood something. So this should just be pure.id, I think. Okay. Pure A. I just realized you can't see this. Sorry. My bad. But this doesn't work. Why would I ever eta reduce? No. Heated legacy code. So let's actually do the following because I'm a little confused. A GHCID C stack. I don't know why I haven't just put this up here. All right, so we have. I feel like, by the way, my implementation of these things is maybe incorrect from like what it's supposed to be, but I'm not 100% sure. So what's the type here? This is a no. What's the type here? This is a BA. And I need a T, an M, and an A. I have an A, but I need to unwrap it. But it's a monad? I think it actually complained, but maybe? I'm now curious. It seemed to like complain that it wanted the other ones. If I like when I wrote applicative, so let me do this. But yes, it does seem to work that way. But when I wrote applicative, watch what happens. Well, okay. Oh, well, hang on. The whole thing's failing. So let's put monad back here. Yeah, so it basically starts going up. So it's like it requires it requires all of them. It can't figure this out apparently. Unless there's like possible fix, uses standalone. So anyway, I think you need to, oops, this one. I think you just need to add all of them, unfortunately. Functor, applicative. I don't understand this yet. So this is a B. Wait, what? That's interesting. But it's actually a good point. Weird. Is this right? How strange. Wait, monad didn't even have a functor constraint before? I vaguely remember hearing that it had at least, or it did, I I knew that at one point it didn't have the applicative constraint. Greed, thank you so much for the follow. Feel free to participate in chat. We're just kind of hanging out. I'm attempting to make sense of Haskell, but no, it's hard. So I guess these can just be lift based then, huh? Is that the idea? Is it? Wait. Isn't this just an infinitely recursive function? Oh, interesting. I didn't know that. So if I look at the type of this, yeah, isn't this just, can't possibly be correct. Because these are just the same functions. See, VA, TMA. Although that's the right side of the function. It's not showing me the type here. What is the type here? I don't know how to test this, so I'm a little confused. Also, why are these alphas here? Why can't they just be A's? Oops. Oh no. Yeah, I'm a little confused by that. All right, so this actually does work. Because I'm taking a BA and I'm lifting it into T. I guess. Yeah, I thought that was kind of interesting. I know that Haskell plays nice with these characters, but I've literally never written them. Like, can I just write A and this? Like, why do I need alpha there? I don't understand the point of that. That's probably really hard to read on your screen, but there is a literal alpha here. I don't know why, but okay. There's probably a reason for it, like a historical one. Anyway, I wanted to make sure that these are different lift bases. No, they're not. How do I test this? I don't even know. What if I just write lift? Do I need something like... It just did. That's interesting. So these are literal C macros, right? Or wait. These are C preprocessor macros, right? CPP. Yeah. So that's the first time I've seen these in the definitions, actually. CPP. Preprocessor. Okay. Anyway, the point is that doesn't work. That's why I thought it was going to be... Maybe it's... I'm confused. What's T? So T is monad trans. So just lift. Oh. Yeah, they seem like they could be dangerous though, right? I mean, I guess it's similar to all the other things that like macro-y type things can do. They're like better macro systems in other languages, right? Like that's a thing that exists. Um, I don't understand how to implement this. Basically, BA is the same as MA, so that id gets us there. Maybe I need to explicitly do the following. I think this matters. Fair enough. Yeah. I think I knew that, but not really. I'm confused. So TM I'm confused. Jappy is back? He is back. That's actually a good point. I figured he was going to sleep. It's very late there. I don't understand what I'm supposed to do here. I gotta read this again. Notice that the types in both arguments coincide. Then write the code for the instance that lifts an operation from a monadic stack M one additional layer T. Like, I know I need lift, I just don't know how I need lift. Does that make sense? So the let me read this. Yeah, that's what I was thinking too, but how do I get it out? I don't have B, so I don't know how to get it out. Right, I don't have like a data constructor to mess with here. Like I have lift and lift base. What if I do something like this? Could I like put a hole here? See, the thing is it doesn't ask for all these constraints, which bothers me always. Oh, what's T0? And that's a T. Super confused. Oh, maybe it is that. I don't know if I wrote that. Just, no, I did. I'll add it to the list. So that is... See, the thing that confuses me is, if I just write lift based, isn't that just infinite recursion? Those are not the same function. Those are literally the same functions. But I don't even know how to test this, so I'm very confused. I don't know how to do this if I can't pull out an A. Wait, don't these imply the same thing? Can I just use bind? Doesn't M imply B or B imply M? Something like that? Can I just, like, bind and then lift? What's the point of that? I feel like either I'm drastically overcomplicating or I just don't understand what I'm doing. One or the other. B. But I don't want to change. See, that's the thing. If I wrote B with TM, that makes sense. I'm super confused. Although something makes me want to write the following based on the text that it wrote. All right, so this one, it makes perfect sense now that I'm looking at it. I'm really dumb. Yeah, I think I'm overcomplicating it. But yes, this one type checks. So you can see it here, right? It's so stupid. Okay, monad trans T. Here's that T. BA-MA. That's lift base. And then we just need to lift. So that's the extra T. I'm just dumb. My apologies. If you wrote it like this, it might be easier to see. Well, you can't, but... that gets you the BA to MA with the lift on the outside from here. Now, the one question I have... I mean, I say that really negatively, but I do learn... I'm a learn by failure person, so I tend to be hard on myself for that reason. When I fail, I learn a lot faster, so watching me struggle through this is really just the way that I learn things. And I feel like I've learned some pretty hard things in my life. And it's usually this kind of same process. But anyway, thank you for saying that. It's nice of you to say that, at least. Sometimes I'm way too hard on myself. Okay. No, wrong button. I don't understand why it doesn't want to format this at all. Very confusing. It probably has something to do with the language extensions I have enabled. That would be my guess. Okay, anyway. This is a lot easier than I thought. I was just doing it backwards. I had written the inverse of this multiple times, I feel like. But the types say all. Pay attention to the types. I haven't done Haskell in 2 weeks either. Well, actually, yes. In 2 weeks. So, I'm slow. Okay. At the end of chapter 8, we introduced the prim monad type class, which defines those monads that have a notation of mutable, the notion of mutable variables, such as IO and STS. Using that type class, we could create computations that are independent of the kinds of variables we use. It says fact do I feel like this is gonna get somewhere. Interesting. There's something. There's actually in a package called lifted base. That defines some. Hang on. So, for example, we could write something like put sterlen monad base IOM string to M unit. But apparently, Haskell only defines string to IO unit for put sterlen. So apparently there's like a lifted base that allows you to do all three of them. So I guess there's some interesting type classes that allow that to happen. We should probably look at that at some point. What time is it? Okay. Okay. It's 9 p.m. where I am, by the way. If you're curious. Lifting functions with callbacks. That's the next. We're on section 12.3. When is the next exercise? Feels like it's a million hours away, but it's really not that far. Okay. Giving transformers the ability to lift operations from inner monads via lift is a good first step, but it only works for those scenarios where the monad appears only in the return type of the function. However, consider an operation such as m plus. Oops. Just for reference, m plus is there you go. Okay. A little hair under there. Here, the monad m also appears in the argument position. Lifting this operation should change all occurrences of m to tm, resulting in tma, tma, tma. Right, so if we wanted to lift m plus, we need something like this. Can't do it. Okay. Do. All right, so one could try and write the following. It's not going to work. Oh, I was right, by the way. All right, let's see what kind of weird error we get from this. Where does m plus come from? Control monad. Okay, so save this and then go look here. All right, so we got TMA. So it seems to me like we might need an F map here, which I suppose is not that surprising. Maybe. Oh, I see the point here. Okay, so this is the unlifting part. So M plus has a type MA, 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 but we're currently with TMA, TMA. So what we need to do is unlift the outer T so that we can use M plus. That's the idea. So we need something like the following. So lift $$ M plus unlift something like the following. So monad plus M. I just want to see if I can get this to... There it is. Nice. So that's what we need to define. I wanted to use the whole because I like the whole driven development thing. Not this. So basically we need a function unlift that is of type TMA to MA, i.e. like unwrap the outer layer kind of idea. Okay. It says, as we'll see in a moment, it is not possible to have an unlift operation that works as seamlessly as the code above suggests. Okay. Sorry, I'm trying to find the answer here. Another source of functions that require unlifting are those that require a callback function as an argument. The simplest example is catching an error using monad error operation. If we want to lift, okay, I see. Hang on, let me write this. Catch error. I don't know where this defines, so we'll just leave it like this. It might allow us to define this. I don't want to bring this into scope, so if we want to lift catch error through a transformer, we need something like this. All right, so this is the problem, is basically that this unlift function is hard to write, but this should look something, I guess, like the following. So, or we want it to look like this. Lift, catch, error, unlift, C, unlift, dot, H. That's what we're hoping to write, essentially. Okay. Same pattern of callbacks as arguments is common when dealing with resource management and I/O. Take, for example, the bracket function. Okay, so it says in the following sections, we will discuss several ways to implement it, each with different trade-offs. This is kind of interesting, actually. Okay, so targeted solutions. One of the advantages of monad trans is that by providing only one additional operation, you unleash a lot of power to move operations among transformers in a generic and usable way. Providing an unlift operation with similar characteristics leads to complicated designs that push the type system to its limits. As a consequence, some libraries in the Haskell ecosystem have decided to target only one specific area of unlifting, resulting in simpler to understand interfaces. We already introduced the type class that targets the error handlings. Okay, I see. So it's like specifically monad error. So let me go look up monad error. Error. Wait, but this is catch error. How do we get the lift? Okay. So there's monad error. Oh, I see. So for every transformer, there's just an instance for monad error. So you can just that's how you get the stacks through. Okay. It says the other main source of functions with callbacks is IO. The unlift IO package defines a specific type of class, monad unlift IO, for unlifting from several layers up to IO. Okay, so let me look at that one. So monad unlift IO. Unlift IO core is probably this one. Okay, so it says to look at with run in IO. Oh yeah, I can see the type system being constrained or like stretched here. It's pretty tough. Well, I guess it's not that bad. All right, so it says a call to with run in IO is usually written in the form of an anonymous function. Argument to this function, which takes the type for all a ma to IOA, represents how to move down the monadic ladder all the way to IO. Using that helper, we have to build an IO operation, which is then lifted to the entire stack. Okay. All right, so we're gonna try and do this. So we need unlift IO core. And then we need control monad IO unlift. And we need to do this and this. And that should be okay here in a second. So we'll take a sip of water. Come on. There it is. And we're gonna have to kick this in the pants. Okay. I don't recommend violence towards you others. Thank you very much. Okay, so now we need to lift the following function. So we're gonna write the type signature here. We're gonna write with file, but the monad version. So with I feel like the only thing I need to change is the... Where'd this go? All the IOs just become M. Monad unlift IO. So with file prime monad, oops, monad unlift IO I don't remember where these things come from. The beauty is I don't have to. System IO. Oh, I need an M. Okay. So all right, so file path IO mode and I forget what with file is doing. What does with file do? What's the purpose of this? Just opens a file. Passes resulting handle to the computation ACT. So this is the computation. So give it a handle, do this IO, and then perform that. Okay. So what do they call this? Action? Act. So we need to basically do with run in IO with file something like this. Yeah, it's not a run and act are both functions. So here. So this is our original action, and this is the function that is basically lift base, I guess. Okay, neat, I guess. I don't really know what this means. Oh, I need to this is exercise 12.3. Write the lifted version of with file. Why does anyone know why these sort of core libraries are being moved out of where they were? Are they like under new ownership or something? I'm a little confused at why that's the case. I mean, I guess this is Unlift.io. This depends on Unlift.io core. Okay, so this is like all the usability pieces. I see. Well, I think I see anyway. Interesting. Okay. Anyway, we only need an Unlift.io core in this case to implement this. All right, so Monad Unlift.io is the first example of a class of transformers that is not inhabited by all the transformers we introduced in the previous chapters. In fact, the set of stacks that supports with run in IO is small. It only allows reader T layers down to a base IO at the bottom. We will describe the problem in the depth later in this chapter, but in brief, a monad for which the execution of the same computation twice may change its visible outcome cannot have a well-behaved monad unlift IO instance. We say that monad unlift IO only works for stateless monads. In the case of lifted base, the package unlift IO provides versions of IO operations in the base library already lifted and ready to use. Note, however, that Unlift.io is, at the moment of writing, a young package. So the ecosystem around it is still in flux. It looks like it's been... Well, let's look. What's FPCO? July 15th? Is this a Snoyman thing? Oh yeah, it's FP complete. Okay. So I think it's Chris and Michael are the founders. I don't actually know who the exact founders are. So don't quote me on that. Interesting. Okay. What's next? So it says there are two details worth mentioning about Monad Unlift IO. First, it only targets monad stacks with IO at the bottom. Are there... Wait. I thought that was the only place you could have IO. Was at the bottom. Anyway, the second is that the unlifting operation is only available for stateless monads. The monad unlift package retains the latter restriction while dropping the former. Okay, so it can work with IO anywhere while dropping the former. Lifting through one transformer layer, for which we mainly use lift from the monad trans type class. Alright, so apparently there are two type classes for dealing with this in monad unlift. I can bring it up here. Monad unlift. Unlift. There's monad trans unlift and monad base unlift. Okay, interesting. So this one is a dual to lift. Yeah, so monad trans unlift gives you like unlift. Monad base unlift gives you unlift base, like lift base, but unlift base. Okay. Interesting. So it basically just requires a little bit more ceremony, I guess, is what we'll say. So let's see if we can write the version. Monad unlift. Is that what it was? I think so. And what we'll try and do is write the other instance basically. One viewer, hashtag sad. And then let's just get rid of this for now. We don't need it. I need monad trans unlift. And we need to restart. Need to save a few times. Well, actually, we just need to wait. Usually, figures itself out here in a second. And then we're going to write a new version of with file that's going to take monad base unlift m file path IO mode handle. Here, let me. Okay, so this time we need do, apparently. Maybe we don't, we'll figure that out here in a second. We need unlift base run. Oh. Ask unlift base. Then we need lift base with file fpm run.act. Oh, we already had flexible context. What? The constraint. I don't understand. I mean, this is just a warning, but I don't know what this is. Matches an instance declaration. or simplify it using the instance. I'm not really sure what this means, folks. That's the code I get. Okay. So I'm looking for instances of. Is there any mention of IO in here? So this is the thing it's complaining about? I'm not really sure how to fix this. I don't fully understand what we're doing here. Maybe we can do some Googling. Let's see if this brings anything up. Straight synonyms? Oh, so maybe I should just define a type. Let's do that. Wait, but then how do I do the constraint? Okay, so constraint kinds. This just does the same thing. Monolocal binds. I don't know what this means. is probably something I can't comprehend at the moment. All right, I need to quickly use the bathroom, so just give me a second. I'm sitting here for too long. What was it called? Mono base monolocal. Okay. There we go. We're back. Look, it's me. Okay. So okay. Sure. I tried some other thing, didn't work. So let's try this. I don't fully understand why that's necessary, but that's fine. Probably has something to do with the fact that I have... What if I just did... Ugh. I don't know. It's probably fine. Sorry, something in my eye. Hey. So how's everyone doing? Pretty quiet all of a sudden. Anyway, I wanted to write that. Got a eyelash. Sorry. Okay. I think we're okay now. Alright. The one interesting idea from the monad unlift ecosystem is how it works with the restriction of monads being stateless to provide its own versions of writer and state. The trick is simple. Use a reader monad that holds a mutable variable. Type of references you want to use, IOREF, STREF, etc., is given as an additional value. So writer ref t. Well, let's look up reader FT. Oh, state. Can't type. The one thing I'm interested in is seeing who wrote this. Oh, that's funny. Also, he wrote both of these? That's kind of interesting. The guy's insane. Good insane, not bad insane, clearly. Since in both cases we just hold a mutable variable in the environment, the implementation ends up being the same in both cases. However, the interface that monad unlift provides is different. Monad writer in the former case and monad state in the latter. Okay. In order to execute the computation, we need to choose the kind of variables to use and thus the base monad in which the operations are to be performed. So there's apparently a run state IO ref T somewhere. Run state IO T. This one. In principle, the idea of simulating state by using mutable variables is safe. Furthermore, in those environments where we are using IO anyhow, it can provide a good performance boost. Still, the use of these transformers remains quite rare in practice. I wish they would show examples of it being used. Is there a way to like search for things that depend on this? Oh, I see. Okay, so apparently the Rio thing. Oh, this is like an older solution to the same problem, seemingly. Or the unlift thing. Just depends on unlift. I don't know how to figure out how it uses unlift internally to make itself work. But you can see it depends on unlift IO and unlift IO core. At some point I would like to understand what this thing really is and how to use it, but we'll get there eventually. I think maybe by the end of this we'll have the tools to figure that kind of stuff out. Okay. This is the end of our trip of increasing power and more convoluted design in unlifting. The package monad control provides two type classes, monad trans control and monad base control, which allows us to lift and unlift across almost every transformer. It says, but with great power comes great responsibility. We can write code that exhibits a surprising, some would say plainly wrong behavior without even noticing. Okay. So the basic idea of monad control is similar to unlift IO and monad unlift. It provides a way to get a function that performs the unlifting. However, once we depart from the world of stateless monads, a function with the type TMA to MA is not enough for the following reasons. If we are unlifting from a writer T transformer, we need to give back both the result value and any changes in the value that are accumulated along the way. We therefore require a function with the type writer T MA to M a tuple of AW instead. The same holds for state T. The function in the unlifted position also ought to define how the state changes. In the case of maybe T or except T, I don't want to keep reading. Very bored of just reading. Want exercises. We just make a book where every page is just full of exercises. That's what I want. This tells us whether the... I'm not going to read that. Okay, so the connection between each transformer and the additional information it needs for its unlifting operation is given by the STT type family. Roughly, a type family in Haskell works as... I know what a type family is. Okay. Okay, so lifting and unlifting via monad control is done in 3 steps. Obtain the unlifting function using lift with. It says the obtained function is not of the form TMA to MA, but instead a slightly modified TMA to MA STTPA to account for the additional information saved by the transformer. Run your operations in the lower monad, unlifting operations as required. In most cases, the code looks similar to other approaches, but you end up returning something of the form MSTT. I know this is really hard to like picture, but we're gonna do an example of it here in a second, hopefully. So we'll try and write the with file one without even looking at the code. That's not what I mean by that, but F package. I'm very tired, by the way. I might end a little bit early because I need to get up at like 6 a.m. tomorrow instead of normally the normal time. And usually I go to sleep very late. Monad control. Put an underscore on this one. Probably need these two things, I guess. I'm not 100% sure. M. Wait, did I import this? Where? What? Why is that okay? Shouldn't this fail? Where's... Okay. Oh, okay. Just trans control. Wait, but I didn't import that. Why is this compiling? Please stop compiling. Okay, it doesn't. Hey, Nandy Gate Awesome. What's going on? Actually, yes, we do. We've done, how far have I gotten? I assume that that's just a misspelling. Or you're trying to get me to log into a malicious website, one or the other. I've gotten to about the resistor color trio. Kind of trying to do them in order. Oh, I've done a few of them. No, that's okay. Yeah, so we've done quite a bit of them, and we've gotten some accepted. There's some cases where I need to go through and like try and do this again. We were actually doing these on Thursdays, but I kind of got bored and I wanted to move on to something else. So we started working on something else as well. So yeah, I've done a little bit of it. Have you done some? It's actually really fun. I kind of like doing it. It's fun to do it in Haskell for me because I get to like practice a lot. Yes, I do, because I try to think. I try to think very carefully about this. So let me explain what I mean. Let's look at this one for example. So actually, let's start here. So Simon, who has actually hung out on the stream a few times. Oh, I've not done C++, but I can tell you the mentors for Haskell have been fantastic, and you know he takes a lot of time to like give you information about what you're doing. So they show you really useful functions and things to try and like change your solution to make it better. And so I think pretty carefully about the way I'm implementing these functions such that I'm writing idiomatic and nice Haskell. So I think I don't know that C++ is the same way. I hope it is, but I would highly suggest doing the exorcism stuff just because I think it's cool, and also you can contribute to it. So it's completely open source, which is nice. We've actually done a few. Contributions to exorcism Haskell track. Yeah. So, give back if you can. I think it's worth doing. Okay, so this failed, but it's not showing up in here, so I think what I'm going to do is just open it again and see if we can get it to complain. I don't know why it's complaining here and not here, but yeah. But yeah, you can just like Google it. I'm pretty sure it's like it's probably GitHub.com exorcism CPP maybe. I don't know if you can put pluses up here. Yeah. So like you can go through and look at the exercises and the tests, and there's a contributing guide. So like feel free to like play with it. It's really fun. They're usually looking for people to help. So, well, I don't know. We can just look real quick. Yeah. For sure. Like any time you're learning a language, it's good stuff. Well, unfortunately the Kenneth Rosen book. That book is. I have a bunch of C++ books at work. This one? Discrete mathematics. No worries. Yeah, I'm curious now. That sounds like a fun book. But maybe there's a more generic. Go away. Oh. See it here, but I don't know what it's called. So also this is some random website. So what if I put C++? Oh, is it this one? Oh, no, that's different book. Problem solving. Oh, I think is this the right one? Oh, okay. This one looked cool. Yeah, I was thinking about picking this up at some point, but I stopped writing. Um, yeah, that's oh, 9th edition versus 10th. I see. Yeah, I mean this is basically free. So, oh well, that's renting. Oh my goodness, that's expensive. Holy crap! Don't buy that book. It's $1,000,000. There's got to be a better resource for less money. My goodness. Free at school. Okay, well, free at school is probably fine then, but that's very expensive. But Exorcism is a fantastic resource. Um, I don't know a ton about that particular track, but I can tell you my experience has been very positive. Abe. Okay, well, this isn't complaining anymore, but I don't understand why, because it should complain. Oh, maybe it's the underscore. Maybe underscore is unhappy. Oh? Not underscore. I don't understand why this is being so confused. Okay, whatever. So control monad trans control. It's funny to say. Control monad trans control. Is this like that's not that's not how you do things. Okay, let's do the following because I'm super confused right now. I mean, it finds the hole, but what if we do this instead? Undefined. And then we remove this. Fail. Why do you compile? It's control monad trans control. It's literally right there. Control monad trans control. How is it finding that? What is happening? Is this like re-exported by some other thing? Maybe that's what's happening. Maybe there's something I just don't understand fundamentally about how these things work. So what if I just start commenting some of these? Well, it's probably gonna fail in other places. Okay, here's what I want to do. I know what I want to do. And apparently we're gonna, oh. So this code doesn't actually do anything. What I'm doing right now is working through this book So it's called Book of Monads. You can see my code. There's an Amazon link as well. But we're just working through the chapter of this book and basically just trying to solve the problems that that come up one by one. So like the whole thing about today is learning about what's called lifting and unlifting. So let me show you an example. All right, so this is like an example of lifting. So I'm taking some thing that has this type and basically converting it to something with this type. So like think of it like adding another layer on the outside, something like that. And so this if you've never done Haskell, this is going to be like jumping to the deep end pretty quickly, unfortunately. But I can convert a BA into an MA because of this thing called monad base, BM. So this thing gives me the ability to run this function, and I can show you the type. So if we look at lift base, it has a BA to an MA. All right, so I can convert this thing that's given to me into this thing. And then what I'm going to do is take this thing and convert it into this whole thing. And the way I do that is with this lift function. So if I look at the type for that, you can see I take an MA and convert it to a TMA. Now, there's some cool stuff in Haskell that basically allow you to ignore any arguments. You could write this like the following, like that. So it's basically like, given an A, which is this, has this type BA, I can prove it to you by doing this. Well, it's not playing nice now. But anyway, this has type BA. I can just apply these functions subsequently. So that's the same thing. Or I could write the following. This means exactly the same thing. So it's like do this thing, lift base A to give me MA, and then do lift to give me TMA, right? Something like this. But in Haskell, you can do this thing called eta reduction. And eta reduction basically just means that if your input is the last thing on the line, you can basically just remove it. So this is completely redundant, and you can just write instead lift.lift base. And like that might not seem like a very useful thing at first, but it turns out to be pretty cool. And so there's actually, yeah, there's ideas like that. It's like just build a pipeline of functions to do something, and you do that really often in linear algebra. So yeah, it's kind of like that. Build your pipeline, ignore your input. Eta, ETA, yeah. I can see how that would be hard to hear though. Yep. You can actually just like look it up. Oops, wrong thing. Eta reduction. Yeah. So these functions are basically equivalent. That's the idea. It's pretty great. There's a lot of cases where it actually, so we actually have a, I said something a while ago and we sort of use it as a, you have to be kind of careful though. There's actually like a thing called point, I'm going to the wrong thing. Pointfree.io, and like you can write like arbitrarily, no, it's not arbitrarily, pretty complicated code in here, and it will give you the point free version. Sometimes though, the point free version is like unreadable, and you have to be very careful. So we have this saying where it's like point free for the sake of point free. That's PFSOF, PFFTSOPF. And you have to be careful not to do that, because you can write like a really terrible point free code. It works the same, it's just really hard to read. So I forget what the term beta reduction refers to. It's like replacing one thing for another thing, right? Yeah, yep. So there is beta reduction that you can do in Haskell as well. Yep. So like if you're trying to evaluate what actually happens at the runtime, you do like beta reduction for lift base, and you start filling in all the pieces for lift base to define its solution, essentially. So because Haskell is based on a typed lambda calculus, you can do really nice things like that. So what's amazing to me is I didn't know any of that at the beginning of the year. So we've come a long way in a year. I've been streaming since basically January 1st and learning Haskell. I've done Haskell a little longer than that, but I feel like we've gone quite a long way. All right, so anyway, this is lifting. There's also like, yes, that's true. So there's like this weird balance between like readability and you know, letting the compiler do its thing. But there are cases where point-free code is faster than point-full code. Not sure if that's the right term. Yeah, so there's also like, so that's like lifting. There's also this concept of unlifting. So if you have a function like this one, where it's like MA, 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 and you want to lift the whole thing, you end up with, you know, you want to write like M plus prime or something, and it has this type. The problem is that if you want to use M plus, you have to like create some function called unlift to deal with the fact that your X and Y are both TMAs and you really want MAs. So there's this generic concept of unlifting, which is kind of what we're exploring now. These are 3 different ways to deal with this unlifting process, and they all have pros and cons, and I'm not sure I fully like cemented in my brain the different pros and cons between these things. But my understanding is that this one, according to the author of this one comes from Monad Unlift, has deprecated this in favor of this one. So I think that this is the most, this first one and this third one are the most obvious ones. The problem I'm having right now is that I don't understand why this code is compiling, but I think it's because there's some export of this constraint that I don't know where it's happening, and it's just kind of happening. So, but okay. Anyway, so I think this becomes, and what we're doing right now is basically dealing with a like a function that does something on a file. That's the idea. So you can unlift. You can use this unlift idea to deal with any monad. And the right way to say that? I don't think that's the correct way to say that. I think I'm misunderstanding how to explain this. It says same pattern works for operations that ought to be lifted from a base monad instead of through a transformer layer. Interesting. Okay, so hang on. So this is basically what this looks like. Thank you. I try. It's really, I mean, it helps. The more you can explain things, you know, the more it's, you have to cement it in your own brain. And the only way you're going to be able to do that is by being able to explain it to others, right? It does help that I am a teacher. I do teach quite often. So I think that being able to explain this stuff comes a little more naturally to me. There's a Andre behind me. You can see him. That's my kitty. Come here, Andre. Come here, bud. He's Andre 3000. Yeah, but to be fair, it's taken me a really, really long time to get even close to the ability of explaining this code. And I'd really like to be better at it. I'm just not very good yet. I'm hoping that I can teach Haskell at some point. Okay, so we're gonna say lift base with run. So this defines lambda, by the way. You just need a slash and then whatever the lambda is going to take in. In this case, it's going to be. I'll show you the type of that function here in a second. And we're just wrapping this with file function. So fp im, and here's where things start to get a little hairy. Run R, which is the action, and the H, which is the handle, I think. And then you write restore MX. So here's a situation where we don't need H, right? We can just do the same, very similar thing to what I showed you before, where you can just write run.act, and it's the same exact thing. So like you have this eta reduction of the H, and this code looks very similar to this code. The only difference here is this lift base with versus with run in IO. And then also you need to do this restore M thing. But if I looking at this, I'm pretty sure I can rewrite this code as well so that it doesn't even need to do. And I'm actually surprised that it's not like trying to do that for me. But I'm pretty sure that I can just bind with restore M. So I think I can do the following. And I don't think I need these brackets. So this is actually the same thing. I'm not sure that it's any more readable. I mean, it kind of is, but let me go back to the other solution to explain a little bit more. All right, so since you've never done Haskell before, there's probably a few people who have never done Haskell before. A do block basically abstracts over this bind syntax that you get from Monad. Yeah, probably. So like here's that case. Here's a case where we could take this. Yeah, I think I need another dot in there, right? I think I need this, right? So like you can see that this starts to get pretty hard to read if you're not used to it. But I have seen that pattern. Yeah, this is this Blackbird? I thought Blackbird was different. It's kind of like Blackbird anyway. Yeah. But basically, if you see this pattern a bunch, it starts to become more and more obvious that you know what it is. But I think this is one of those things that you just have to look at for a long time. And cat's being bad. You just have to play with it a lot and get used to it. I think I'm gonna leave the run in there for now, just because it looks a little. It just looks similar to these, and I don't want to change a bunch of them for now. And we'll leave the do in here. So anyway, so the point is, why is nothing working? Oh, because I was screwing around with this. My guess is that this should just compile. Unless there's some other error that I don't, seems fine. We should restart this just in case, because I don't remember when I did it. So it is fine. And then we should be able to start getting types. Okay, here we go. Oh boy. So. Yeah. Yeah, this is tough to read. This is pretty tough to read. I'm not sure I could explain this very well. But I think the general idea what is the general idea? I gotta read this again because I'm confused. Okay, apparently this lift base with and restore M thing is so common, there's another function to just make this a little easier. You can just write control. Ooh. We have our first error. That's so strange. I don't understand why it's erroring like that. So we could bind that to whatever that function was called before, restore M, but there's also this control thing. So here's a situation where you can start doing like really interesting things, because you can start like removing pieces. So we could stick this whole thing into I don't know if you're even still here, but I imagine that this would look pretty funny. See? So you can do some really wild things with point free notation, and this obviously decreases the readability to essentially 0. Yeah, there's the classic Blackbird. Yeah, almost. Like you're almost at that point. You're missing a few outer parentheses, but more or less. There's a few folks in chat that are super into like Lisps. I haven't seen Lumi today, but we talk about closure quite often actually. But I think like the most readable version of this would be to just remove run, and you might even be able to remove act, and it might be okay. So like you could do let's see. So what we did before, which was dot like this, and then if we wanted to remove act, I think we could just get rid of act, I'm pretty sure. Maybe I don't know that analogy, so I can't answer that. So this needs to be to dissect Kingberg. Unfortunately, I don't know what that means in this context, so I can't. We need another dot here. I don't even want to think about this. It's already more complicated than I would like it. I don't even like this. Let's just keep running. Okay. Blackbird. David. So, is this it? Oh yeah, to dissect a mockingbird. Yes, I think it does mean this. But I don't see blackbird in here at all. But maybe it's this thing, to mock a mockingbird, that Smulian. Anyway. But probably I don't actually know where that comes from. Okay. Anyway, I've been distracted. What time is it? Okay. Unfortunately I have to go. I need to get up really early tomorrow, and it's already later than I wanted to stay, but that's okay. So next time next Tuesday, we're going to keep working on this chapter. So there's a little bit more of this lifting and unlifting, and then there's manipulating stacks, and then we're basically done. So it's manipulating stacks, and then monad morphisms, and then the next chapter is all about like rolling your own monad stacks in different ways, I think. So it's like defining custom monads essentially. So we'll see how that goes next time.